Welcome back to the deep dive. Now, if you're prepping for those ATPL exams, you definitely know that performance and navigation questions, well, they often boil down to understanding distances, specifically distances in the air versus distances over the ground.
That's absolutely right. It sounds simple, maybe, but it's such a fundamental concept. And honestly, it's where a lot of subtle errors can sneak in to flight planning. And importantly for you right now, cost you points on the test.
Exactly. So today we're doing a really deep, detailed dive into nautical air miles, that's NAM, and nautical ground miles, NGM.
Yep. And these aren't just abstract ideas. You see NAM and NGM cropping up everywhere. Performance graphs for single-engine pistons, multi-engine pistons, even those big medium-range jets. They all reference these concepts.
So our mission today, it's really to get past just the basic definitions. We want you to truly master the two main calculation methods you'll need, give you that conceptual clarity and the mathematical tools for quick, accurate recall right when you need it, under exam pressure.
Precisely. It's about building that solid toolkit.
Okay, first things first. Mastery starts with defining the territory, right? Let's pin down that absolute non-negotiable distinction. When we talk nautical air miles, NM. What exactly are we measuring?
Okay, so NMM is purely about the distance the aircraft covers based on its speed relative to the air mass it's flying through. Nothing else. It's all about your true airspeed, your TIS, how far you move through that parcel of air.
Got it. Through the air. And then nautical ground miles, NGM.
NGM is, well, it's the practical one, maybe. It's the distance you cover relative to the fixed surface of the Earth. It's literally the track lengths over the ground, what you'd measure on a chart.
Right, the line on the map from A to B.
Exactly. And that distance, NGM, is governed by your ground speed, your GS. And understanding the relationship between NAM and NGM, well, that's the core of this whole deep dive. That's where the math comes in.
Okay, let's really nail these definitions down then. NAM. Purely distance covered through the air. Think of it like how many miles the wings have physically sliced through that volume of air, right? It doesn't matter where that air itself is going.
Perfect analogy. It's an aerodynamic distance. It's essentially tied to performance. And NGM, that's your navigational distance. Point A to point B on the map, that's your NGM.
Simple enough in theory. But the complication, of course, is that the air itself, it's almost always moving relative to the ground. That's the wind.
Exactly. And that's why this matters so much for performance calculations. Your aircraft's performance, fuel burn, engine efficiency, that sort of thing. It's tied directly to TAS, and therefore to NAM. But your navigation, getting to your actual destination, depends on covering a specific NGM.
So you absolutely have to be able to convert between the two.
You do. Which brings us to the starting point, the baseline scenario. When is an AM exactly equal to NGM? When do those two distances match up?
Ah, the ideal world scenario.
Sort of. This is key knowledge point 1, really crucial for checking your understanding later. NAM equals NGM only when the air mass is completely still relative to the ground. Zero wind.
Okay, no wind. Air distance equals ground distance.
Well, to be technically precise, it's when there's zero wind component along the aircraft's heading vector. You could actually have a crosswind, wind coming directly from the side.
Oh, interesting.
Yeah, if there's no headwind or tailwind component, even with a crosswind, your TAS might equal your GS, and your NAM will equal your NGM for that specific moment or leg. But generally, we simplify it too. Still air means NAM equals NGM.
Okay, that makes sense. But like you said, the real world usually involves moving air. So let's bring in the wind component, WC. This is where things get interesting and where those performance graphs start to click.
Right. The WC is just the speed and direction the air mass itself is moving across the ground. And because, as we said, performance graphs often use NIM, you must be able to translate that air distance into the ground distance you need to cover.
Let's visualize the headwind first. That's a negative wind component, right? The air is moving against your direction of travel.
Yep. Picture the air literally trying to push you backward. It's resisting your forward progress over the ground.
Okay, so what's the result? How does that affect NAM versus NGM?
This gives us key knowledge point 2. With a headwind, you always fly.
All right. Many thanks for listening to this free part of the ATPL Theory podcast. If you want to continue learning and access the full comprehensive guide, go to my Patreon at patreon.com/ATPLtheory or my Hero at herohero.co/ATPL. That is patreon.com/ATPLtheory or herohero.co/ATPL. Wishing you all the best